All right, you guys, in this video, we're going to be talking about the higher powers of I. So our directions say to find patterns that will help us when finding higher powers of I, we can use these relationships. So we know that I squared is equal to -1, and we know that I is equal to the square root of -1. So as you're looking at this table, okay, you will see that no matter what our power is of I, that the values repeat every fourth term, okay? So like I to the 0 is equal to 1, so is I to the 4th, and I to the 8th, and I to the 12th, all right? I to the 1st, I to the 5th, I to the 9th, I to the 13th, they all come out to the same answer, which is I, so on and so on for the table. Okay, so how this is helpful, because the powers of I, their answers repeat every fourth term, it doesn't matter what our I is raised to. So for example, if we had I to the 100th power, if I wanted to figure out what that equals, instead of multiplying I by itself 100 times, I could ask myself, okay, well, how many times does 4 go into 100? And does it leave a remainder? Yes or no? So for 100, okay, 100 is evenly divisible by 4, okay? So the remainder would be 0. So that means that I to the 100th power is the same thing as what I to the 0 is, which according to our table is 1. Okay, so if you ever want to find out what your answer is if you are doing a higher power of I problem, okay, step 1, you're going to take your exponent, okay, and you're going to divide it by 4. Okay, when you do that, okay, you will raise I, okay, to your remainder. Okay, so whatever your remainder was, you're going to take I and raise it to that remainder, and your remainder is going to be one of these 4 options. Either it's going to be 0, which means that 4 went into that number evenly, your remainder is going to be 1, your remainder is going to be 2, or your remainder is going to be 3. So any higher power of I problem can only have one of 4 answers. Either your answer is going to be 1, I, -1, or -I. Those are your 4 choices. Okay, so let's do some example problems until you guys get the hang of it. Okay, so in this example, it says find the higher powers of I. Okay, so let me write those 4 so we don't forget. So I to the 0 is equal to 1. I to the 1st is equal to I squared is equal to -1, and I cubed is equal to -I. Okay, so for this first problem, I to the 11th power, we're going to take 11, we're going to take our exponent, and we're going to divide it by 4. Okay, so we're going to ask ourselves, how many times does 4 evenly go into 11? Well, it goes in there twice. 2 times 4 is 8. We're going to subtract it, which is going to leave us with 3. That's our remainder. So what that tells us is that I to the 11th power is equivalent to what I to the 3rd power is, which is our remainder. And we know that I to the 3rd power is equal to -I. Okay, so that's our answer for the first one. Okay, let's look at B. So we're going to do the same thing. We're going to take our exponent, we're going to divide it by 4. Okay, 4 goes into 36 9 times. It goes in there evenly. So when we subtract them, we have a remainder of 0. So that tells us that I to the 36th power is equivalent to what I to the 0 power is, which from our list, I to the 0 power equals 1. Okay. All right, let's do C. Let's move it over here. So we're going to take our power. We're going to divide it by 4. Okay. 4 goes into 72. Let's see, 4 goes into 7 once. So that would be 4. We're going to subtract 32. Goes into 32 8 times. So it goes in there evenly. Okay. So our remainder is 0, which tells us that I to the 72 power is equivalent to I to the 0 power, which equals 1. Okay. All right, let's try the last one. So for D, you'll notice that our exponent is negative. Okay, so when we talked about our laws of exponents, we know that if we ever want to make our exponent positive, we can change the levels of our problem. So we had this rule, our negative exponent rule, that if you had x to the negative n, you could change it to 1 over x to the nth. Okay, so instead of saying I to the negative 16th power, we're going to say 1 over I to the 16th. And our rules are still going to apply. So we're going to take 16, not square root. We're going to divide by 4. 4 goes into 16 evenly 4 times. I'm going to subtract. Our remainder is 0. So this tells me that I to the 16th is equivalent to I to the 0, which is 1. All right, so in our problem, that means we have 1 over 1. We just found out that the denominator equals 1, and 1 over 1 is 1. Okay, so you just have to remember whatever your exponent is, you're always going to divide your exponent by 4, and then you will raise I to whatever the remainder is, and your remainder will be one of these 4 choices. Okay, cool.